Hello, and let's finish off section 5.2. In this example, we were just doing scientific notation, putting numbers into scientific notation. You need to also be able to take them out of scientific notation. So with 6.2 times 10 to the 4, you're going to take your 6.2 and move it, take that zero or that decimal and move it 1, 2, 3, 4 places. Oops, 1, 2, 3, 4. And add the zeros for each of those. So your answer would be 62,000. Same again with the negative, except this time instead of moving to the right, you're going to move to the left because the negative means it's a small number. And you're going to go 1, 2, 3. And you move your decimal place the numbers of times that exponent exists. Moving on to section 8.2, we are learning about domain, range, and functions. Domain is a set of inputs, or otherwise, like in the graphing, graphically, they are x values. Range is the number in the set of outputs that corresponds to elements in the set of inputs. For example, your y values. So an ordered pair, the domain is your x value, and your y is your range. And for things to be a function, function is a relation in which each first component in the ordered pair corresponds to exactly one second component. Okay? So in order for, say, a set of ordered pairs to be a function, each input or x value can only have one y value to go to. Okay, so let's look at a couple examples of this. So here in that first example, you have the ordered pair 2, 3, 5, 5, 7, 8. And we need to know the domain. And I believe the computer uses something like this, followed by, so this one you would write 2, 5, 7, because those are your x values. Okay, so that is your domain. Your range is 3, 5, and 8. Those are your y values. Okay, and the other thing it's going to ask, is this a function? And yes, it is a function. Okay, now let's look at this next one. What is my domain? Well, let's look. I've got the x value 2, 2, and 2. So here, when you enter it in, you're only going to put that. Your range, though, will be 7, -3, and 4. That is your range. Now, is this a function? Not a function. Okay? The reason this is not a function is because the input value 2 goes to 7, but it also goes to -3, and it also goes to 4. And that is not okay. You cannot have one input going to multiple outputs. You can only have one input going to one output. But the flip direction does not necessarily work. So here's another example. So here, what is my domain? Well, I have -1, 2, we'll say that's 3, and 5. Okay, my range. So those are my y values. I have 1 and roughly 3. Okay, now is this a function? That's another question. Yes, yes, it's a function. Okay, and the reason this works is because each input has an output, a unique output. I know that some of the outputs are shared, and that's acceptable. You just can't share inputs going to the same. So If -1 goes to 1, that's fine, along with 2 going to 1 and 5 going to 1. That's perfectly fine. And that's all right with the function. As well in this section, you're going to do something called a vertical line test. So you're going to go and look at a graph, and you're going to draw a vertical line. And if that vertical line intersects the graph more than once anywhere, then the graph is that should say not a function. Okay, so here, can I come here and this first graph, if there's anywhere I can draw this vertical line that I hit the graph more than once, it would make it not a function. And you might say way over here, you might be hitting more than once, but you're not. It's going to continue to move out. You're only going to hit it once. So this is a function. But if we come and look at the second graph, if I draw a vertical line, I'm hitting here, 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 here. I've hit 4 times. So this is not a function. Okay, you only have to hit 2 times at any one spot. I mean, so if you had something that you went way over here, but you still hit twice, that's still not a function. If you go way over here and only hit it once, there is some place on this graph that you can hit it more than once, therefore making the whole graph not a function. You're going to get something that looks like this. F of x is equal to 7x squared minus 5. Find f of 2. And all this is saying is that it's a function, that the equation they gave you is a function. And find f of 2. All this means is f of 2 means x is equal to 2. So you're going to find f of 2. And that just means we're going to replace x with 2. So f of 2 is equal to 7 times 2 squared minus 5, which is equal to 7 times 4 minus 5 equals 28 minus 5 equals 23. Okay, that's all you do. But you leave it as f of 2 is equal to 23. You don't divide that 2. That's just saying when x equals 2, the output is 23. And the last thing, we have another example. If f of x is equal to -3, find f of 0, f of -3, and f of 7. So I'm going to make x equal to 0. And I'm going to plug that in to that equation, and it's going to equal -3. It's because I have no x's. The next one, same thing. I'm going to make x equal to -3, plug it into the equation. I just have -3. And the third option, x equals 7, plug that in. Well, there's no x's, so the answer is -3. And that'll happen. So hopefully that was all good, and you'll have a great time with this section. Email me or ask me if you have any questions.